A reactance elements product chart can help account for all the atoms. To show how to use it, we'll first rewrite this equation here, inserting the coefficients and subscripts of 1 and color-coding them. Then it will be clear that we put the element symbol in the center over here, and the product of the subscripts and coefficients relative to that atom on both the reactant and product side. So here you see 1 times 2, okay, all right, that's hydrogen. Here you have oxygen, also 1 times 2 equals 2. Then on the right side, you have 2 hydrogens, 1 times 2, and you only have 1 oxygen, 1 times 1. We can see, hopefully, that hydrogen is balanced, with 2 atoms on each side. But oxygen is not, with 2 atoms on the left and 1 on the right. This unbalanced equation violates the conservation of matter, so it could not occur. Doubling the number of water molecules, changing the coefficient from 1 to 2 takes care of the oxygen, but unbalances the hydrogen. Right? We now have 4 hydrogens here, and what do we have there? 2. It often takes a few steps to balance an equation, since all the atoms have to be balanced one by one. Since a molecule may contain more than one type of atom, you may find that balancing one atom unbalances the other. How can we balance hydrogen while leaving oxygen balanced? Doubling the number of hydrogen molecules by changing its coefficient from a 1 to a 2 balances the hydrogen at 4. And it doesn't do anything to the oxygen, so it leaves the oxygen balanced. Right, there's 4 for the hydrogen. This is now a balanced equation, and this is the reaction which occurs in nature. This is the equation that describes a reaction which occurs when iron rusts, this is the symbol for iron, or when we burn steel wool. Take a moment to complete this rep chart and determine if this is a balanced equation. Both atoms are unbalanced, so let's balance one at a time. In this case, the simplest particle is iron on the reactance side. So let's leave that until last. That can be our final adjustment. Let's start by balancing oxygen. All right, you have a 2 here and a 3 here, so that's not balanced. Oxygen has 2 atoms on the left and 3 atoms on the right. We have to change the coefficient of oxygen and the coefficient of iron oxide so that they yield the same total number of oxygen atoms when multiplied by their subscripts. Remember, we can't change the subscripts, just the coefficients. If we triple the number of oxygen particles on the left and double the number of iron oxide molecules on the right, we'll have 6 oxygen atoms on each side. 6 is the least common multiple of 2 and 3, so it is the number of oxygen atoms we will need on both sides. So let's change the coefficients to 3 oxygen and 2 iron oxide. Now, oxygen is balanced with 6 atoms on each side. But iron is not balanced, with 1 atom on the left and 4 on the right. That's easy to fix since iron is alone on the left, so we just change its coefficient from a 1 to a 4. This is now a balanced equation, indicating that 4 iron atoms react with 3 oxygen molecules to form 2 iron oxide molecules. This is an unbalanced equation for photosynthesis. It indicates that carbon dioxide combines with water to form glucose, this is glucose right here, that's a sugar, and oxygen. Let's balance this very important equation. We'll fill this out by asking a series of questions to balance one atom at a time.